The problem we're starting with, number 4, it's the very back page of your notes, 4.8. And it's talking about this balloon penguin that's like going on this like Macy's Day parade, or Macy's Thanksgiving Day parade, sorry. And it's like being cabled to the ground just so it doesn't fly away. It says 2 cables are attached to the underside of this penguin to make an angle of 48 and 40 degrees with the ground, and they're in the same plane as the perpendicular line from the penguin to the ground. It's a lot of words. All that means is that I can draw, like, that's a penguin right there. It's my balloon penguin. I suck at drawing, so I'm not going to draw that for you. And we'll say that this is the ground. This is what would be like a line that's perpendicular from the ground to the penguin. There it is. So that's like a straight perpendicular if I were to drop it down. However, what we want is a line that goes at a 40 and a 48 degree angle. Now, I had to look this up last class, so if it's something that like it's very important that you know what the drawing looks like, I'll make sure to give you the drawing. But in this case, we want the 40 degree angle to be out here, and I want the 48 degree angle to be next to it on the same side of the perpendicular, if that makes sense. The closer one is the 48 degree. Is it 48 or 46? I'm making something. No, 48 is right. So think about if you're somewhere far away, the angle is smaller to like look to the top of that. And as you get closer, your angle gets bigger and bigger and bigger. So the bigger angles are closer to like the item that we're looking at. So 40, the smaller angle is farther away, the bigger angle is closer to. Everyone okay with my drawing so far? Now, again, I had to look this up last period. I put them on the other side. And so if it's like a question that like could be misconstrued, I'll make sure to give you the drawing, or I'll say something like they're on the same side of the perpendicular. So now it tells me that I want to find the height of the penguin. If the cables are attached from the ground 10 feet from each other, how high above the ground is the penguin? We know that the cables are 10 feet from each other. So this distance is 10 from the point that's 40 and the point that's 48. And then we don't know the height, but that's what we want to find. H for height. Let's separate these. This is kind of like that car problem we did the other day. So there's a car down here and how I redrew those 2 triangles. I want to redraw these 2 triangles as well. So I'm going to draw the triangle of 48 degrees first. It's the same height, still that 90 degrees, 48 degrees. The next one's a little bit longer. Still the same height, 40 degrees. Now I have 10 as this bottom side, but let's think about what's going on here in this shape. In my first triangle, the 10 doesn't apply to that bottom distance on that first triangle. You can literally call that any variable. We're just going to call it x because I don't know what that is. It's not 10 though. 10 is not a part of that. So under 48, that side is called x. Now for 40, we did the entire triangle, not just like this little baby sliver right here. We did the entire thing. So all the way over to the height, this big orange triangle is what I drew. So my bottom distance is x plus 10. It's this entire thing at the bottom. X plus 10. Everyone okay with that? Okay, so we got our pictures drawn. Which trig function am I going to use? Which trig function am I going to use to start solving for h or for x? Sine, cosine, or tangent? Tangent. Very good. Tangent. I'm going to write tangent of 48 equals h over x. And then while I'm here, I'm also going to do that for the other triangle. I'm going to write tangent of 40 equals, in this case, my opposite is as height, and then my adjacent is x plus 10. Are we okay with how I wrote those tangents and those fractions and stuff like that? Everybody good so far? Any questions? Now, on the other problem, we had the height. So we had 100 and we were able to solve pretty easily. I was able to just multiply and solve. I can't solve either of these. Do we know why? two variables. I can't go in my calculator and plug in h or x and get like a real number out. I can't do that. So what I need to do instead is I'm going to do substitution. So if I can substitute in using a systems of equations, then I can find one variable and then I can plug that back in to find the other one. So which one do we think is going to be easier to solve for? To solve for h, to get h by itself, or to solve to get x by itself? H. I think h is going to be easier too, Brooke. Because what do I need to do to get h by itself? Multiply by x. Now I'm done. I got h all by itself. I'm going to replace h in the second equation with this x tangent of 48. So instead of writing h, I'm going to write everything else the same. Tan of 40 equals something over x plus 10. But instead of writing h, I'm going to write my x tangent of 48. Any thoughts on that? We good? You've done all the pre-calc parts now. This is just simply algebra from here on out. You need to algebraically simplify this to get x by itself. I don't want to deal with that fraction, so let's get rid of it. An easy way is to think about just cross multiplying. So just cross multiply to get rid of that denominator. So I've got x tangent of 48 equals 40, tangent of 40, excuse me, times x plus 10. Any questions so far? All right, let's distribute on the right-hand side. I'm literally teaching my geometry kids right now about proportions and ratios, and I make them wait and do the distributing second because I don't want us to lose anything. So that becomes x tangent of 48 equals x tangent of 40 plus 10 tangent of 48. I'm sorry, of 40. 40, 40, 40, 40. I just said it wrong. I need to move my work over there, but my next step is to try and get the x's together so that I can solve to get x all by itself eventually. So I've got these two x's. Let's bring them both to be on the same side so then we can eventually divide something off to get those x's by themselves. So if I want to move it, I'm going to say minus x tan of 40 from both sides. I can't combine x tan 48 and x tan 40, so I'm just going to write them next to each other. And then I haven't done anything to my tan or 10 tan 40 yet. I will do something to that in a second. So I've got x tan of 48 minus x tan of 40 equals 10 tan of 40. We've got one more step, and then I'm going to want to use the calculator. Do you see I've got x in both of those terms, x tan 48 and x tan 40? If we take the x out of both of them, if I factor out an x, what's left? Good, tan 48 minus tan of 40. Equals 10 tan 40. Cool. At this point, I want to get my calculator out and I want to do these. I want to do tan 48 minus tan of 40, and I want to do 10 tan 40, and then we'll eventually divide them. So I'm going to write tan of 48 minus tan of 48 minus tan of 40. Wait, let's pause. What mode should I be in? Why? Because it's a degree. It's 40 and 48. They're both degrees. We got to be in degrees. So let me make sure I'm in the right mode. Yep, I'm in degrees. And I'm going to press enter and I get 0.2715. Okay. So I've got x times 0.2715. And then I'm also going to do 10 tan 40 right now. I don't need to check my mode again. I haven't changed my mode. It's not going to change on its own. So 10 tan 40 is 8.391. And then we divide by my 0.2715 and I get 30.9. Okay, am I done? No, not done. What did I just find? X, where is X? It's the bottom, right? It's like the distance from like one of the cables to like the perpendicular, right? What did I want to find? The height. If you see, and even how I labeled it is nice and clear. Ooh, that's not what I wanted. Do you see how my 30.9 is just nicely in that little blue triangle I have? I can go back over to where I have that triangle, and instead of writing X, I know that that's 30.9. And so I can plug 30.9 in and solve for H easily. We'll just do it next to it. I can even use the equation that I have right there. See how I had tan of 48 equals H over X, and then I solved for H? I can just plug my 30.9 in for the X here and do 30.9 tan of 48 and go immediately to H is equal to whatever. It equals 34.3. All right, now we're done. Any questions? Okay. We are not going to do this problem above it, so you can go ahead and cross that off or just skip it. Now you have done every single thing that I want you to do for 4-8, so we're good on that. We're going to go a little bit backwards because I want to do problems 1 and 2 of this before we go, before I'm done for today. But let's do number 2 and then we'll go to lunch and then we'll come back and do number 1 because there's some background for number 1 that I need to do, but we don't need that for number 2. So number 2 is a calculator problem. So get your calculator out or keep it out if you already had it out. We're doing the inverses of our trig functions. And I'm going to give you more background on what that is when we come back from lunch. But these first few we can do in the calculator pretty easily. Do you see how they have the exponent of -1? That tells me that we're doing the inverse of it. So anything to the -1 means that we're doing the inverse. We did this a little bit on Monday when we did 4.8 word problems. But what essentially we're going to do to get tan to the -1 is we're going to do second tangent, and then we can type that number in. Great question. The problem says decimal degrees, so let's do degrees. You jumped right ahead of me because I was about to say that. So great question. -1.43, and I'm still in. I'm still in my degrees from before, so I don't need to change anything. I get -55.0349. Now, if we were given a positive angle, we'd let it be. We'd say this is fine. However, we're not used to seeing negative angles, so I want it in terms of a number between 0 to 360. So let's think back to our circle a little bit. This isn't a unit circle angle, but we can think and use the unit circle as a good reference. So here's my circle. And basically -55 is in which quadrant? The fourth quadrant, right? It's like I went down this way, -55 degrees. So I went this way, -55 point something something degrees. I don't want it to be the negative angle. I want it to be the positive angle. So what would I do in order to find the positive angle here? 360 minus that number. So either 360 minus 55, or you can think of it as negative 55 plus 360. Either way, it's the same math. Very good, Aiden. So I'm going to just go the opposite direction. So from here, it's already typed in my calculator. So I'm just going to press plus 360, and I'm going to get 304.9651. I'm going a little bit backwards from what I did earlier today, but it's going to make sense when we come back because I will explain why it's okay to be in this angle, this quadrant. All right, we good on that one? All right, next one says sine to the negative first of 0.761. So I'm going to do second sine 0.761. Oops, not regular sine, second sine 0.761. And I get 49.5524. Do I have to do anything to this one? Nope. We're used to seeing it look like this. This is a normal angle. We know where 49 is. It's in quadrant 1. Easy. You good with that? All right, last one. I've got secant to the negative first of 1.98. Now, what a lot of us are tempted to do is see, okay, secant is the same thing as 1 over cosine. So I'll just do 1 over second cos of this number. If you do that, though, we're going to get a no, like non-existent answer or an error or something in our calculator. What I want us to do the reciprocal of is of this number, the ratio, not of the trig function. So I want to do 1 over that number and second cos of that. So we know cosine goes with secant, but instead of doing 1 over cosine, I want cosine of 1 over 1.98. You okay with that? Second cos 1 divided by 1.98. And I get 59.6653. Okay, when we come back from lunch, we're going to do some background stuff. I made the other class take notes kind of over off here to the side and then do these problems. But we're going to break. We're going to go to lunch. It's 11:41, so let's come back at 12:10, 12:15. The Zoomers, you're welcome to just stay on here and just mute us and then just jump back on, or you're welcome to leave and then come back and rejoin. Go to the bathroom, go get your lunch, go do what you got to do. Let me stop recording.